APRC is proud to present today innovations in distillation of essential oils and extracts. We're very fortunate to have Werner Bester with us here today. He hails from Western Cape of South Africa. And before we get started talking with Werner, I'm going to read you his bio, which is quite lengthy. So we've just distilled it to the essential things for the talk. He's got a lot of experience, and he's been doing this for a long time. Werner's been involved with aromatic and medicinal plants for decades. First as a farmer, which is so unique, and then as a grower of plants from seeds and clippings for the industry. With his training as an engineer, Werner then founded the Essential Distillation Equipment Company in 2001. Currently, his plant nursery and his engineering business are both situated in the Western Cape of South Africa. You can see he's sitting right now, he's in his shop, and he provides consultations and research on all aspects of essential oil production. He does design and custom-built distillation equipment, which is quite unique. Project management as well, because you can't just stop sometimes at the distillation when you're doing these projects. And he does these in unique circumstances for clients all over the world. While EDE was initially aimed at serving the need for information and technology in the South African essential oil industry, Werner is now engaged in the design and manufacture and maintenance of distillation equipment all around the globe. It just exploded. And his knowledge and belief in the value and the use of the country's indigenous oils are reflected in his support for the small farmer and his insistence on sustainable farming techniques, alongside with the deepest values of social responsibility for those who ultimately work the land. And that makes Werner quite unique, having a background both in the growing, cultivation, as well as the distillation. So the goal of today's webinar is to give you a brief introduction to distillation and to show you the inside of Werner's shop. Also to discuss how to make on location, as close to source as possible, distillation more accessible for communities, as well as making it more environmentally sustainable. So without further ado, Werner, we want to jump right in and ask you to describe the process of distillation. We have a slide here for people to follow along with, and if you could say hello to the audience and then walk us through this diagram.
Hello, everyone. If you look at the diagram that you see in front of you, you'll see on the right-hand side, if I'm correct, is the boiler, which is the steam supply. There are various types of steam supply. It could be atmospheric, could be pressurized. The boiler itself can work with wood, coal, electricity, gas, liquid fuels, biomass, solar too, in certain small instances. So that's the steam supply. That the steam would go from the boiler. The boiler would generate the steam from the fuel source. It would go into the bottom, in that case, into the bottom of the pot, where in the pot itself would have your plant material in this case, steam distillation, that is a representation of. For instance, plants like lavender, eucalyptus, rosemary, most of your herbaceous plants and some woods are distilled in this manner. The steam would go through into the bottom of the pot, through the plant material, and difference in partial pressures would make that the oil that is in the plant material would then turn into a vapor. Both the steam and the vapor, being gases, would go to the top of the pot, where it would be transferred to the condenser. In the condenser, the vapor and steam is then cooled down and turned into water and oil. The water and oil would then go, in most cases, there are variations of separation here, but in that specific one where your oils would be lighter than water. From your condenser would go into the separator or Florentine flask, as it is normally called, that type of design, which is a continuous flow separator, which means it would continuously separate your water from your oil.
So water is heavier or lighter than the oil? Is that how they can separate like that naturally?
The specific gravity of the water is the oil is less than the water in that case. In that case of that type of distillation, so your oil would float on top of your water, and you would then separate that out by this. Jesus, that's a bit more complicated. You would separate that out. It's a suction that goes to the top of the flask. In that case, in certain cases, you have oils that are heavier than water. Catnip, for instance, where your separator would then be upside down. Your catnip and your oil would go to the bottom, and your water would be on top. And then there are many other oils that are the density or the specific gravity is so close to water that it's in a continuous separator. It's very difficult to separate. Like myrrh, for instance, myrrh's specific gravity is around 99. Or just over 1, and it takes a really long time because it's so close to water to separate. And you'd have to have 3 or 4 separators in a row for it to get the time to float to the top or go to the bottom. From there on, you would take your oil out and the hydrosol on the side arm. Hydrosol or floral water in some cases have the usage or market, not all. If you look also at the rest of the sketch, there would be a hoist. In this case, those pots are either sunk into the ground, and the basket, there would be a basket inside that chain basket. And once you finish distilling, you would pull out your biomass with the basket and transfer it to a waiting trailer or cart for taking away. Basket goes back into the pot, and then you would refill again. They would always, in this case, we're looking from one side, you would mostly have, because distillation of herbaceous materials is quite short, you would usually have more than one pot, so that you could always fill one pot, and while the one pot is being filled, the other one filled and emptied, the other one is busy distilling, and you would just switch over the steam between them. If you were doing something or hydrodistillation or other distillation or for instance of sandalwood that can take 8 hours or more, you would generally, it would be better to work with just one pot, because the time that it takes to fill and empty is nothing compared to the time that you are actually stilling it. The last thing in the sketch is the cooling tower. That would be to cool the water from the condenser down, and also so that there's no water wastage. It's not always necessary, but it does. There's also a variety of cooling options in that sense. But it does promote, where there's little water, you would generally use a cooling tower. If you have a real problem with the water, there's other cooling options that use no water. That specific one is an evaporative cooler, so it does lose a little bit of water to evaporation.
What are the types of distillation? What are the most common types of distillation?
There's only a couple of main types of distillation. So there would be steam distillation, hydrodistillation. Steam is where you put live steam through the material. Hydrodistillation is where you actually put your material in water and you boil it, and the oil and your steam comes off. There is also microwave extraction. There are uses for that. There are fractional distillation, which would be a further down the line of extraction. Those are the simple main types of distillation.
Steam and hydro common.
Steam and hydro are the main one. There are others, which is hydrodiffusion, which is from the top down. There are proponents for that. I have not found that it is beneficial, but I mean, there are cases where it might be. In your steam distillation, there are traditional or water bath type distillation. So generally, there's still a lot of them around. We would consider them really old and inefficient types of distillation, where you would have a water bath and there'd be a fire under the water bath in your pot. Your plant material would be suspended over the water bath, and your steam would bubble up from the bottom through it. But it's very difficult to get enough energy into it to do efficient types of distillation. But that's how it was done in old times. And honestly, there's still a lot of it being done all over the world like that. It's definitely not gone. But that's the simplest way of distilling. And your condenser in that case is sometimes it's not the condenser that you see in that drawing. It could be because the steam flow is so low, it could be a coal, like an alcohol distillation, where you have a copper pipe that's turned into a lot of circles, which sits in a water bath. And I still see them today. They are still around. But they don't work with modern efficient distillation. There's just too much energy going through, and it's impossible to cool it with very difficult to cool it with coils. All the coils have to be really, really big. You would often see older type of distillation where the condenser is bigger than the pot. It's a possibility. Modern steam distillation, it's steam from a satellite boiler, which means just a separate thing generating steam with a much higher efficiency, usually at pressure, because most boilers are pressurized. It's how they come. It's more commonly used in the industry. So you would generally take from what the industry uses. It's easier, easily accessible, easy to get. I don't have to build something new. The steam would be generated by the boiler, and the steam would go through the plant material. The hydrodistillation, once again, hydrodistillation stays hydrodistillation. The rest of the types of distillation are really mechanics about how to handle your material. If you have seeds, you would handle it a certain way. If you have wood powder, you would handle it a different way. If you have resin, you would handle it a different way. If you have flowers, which is the one couple of flowers are distilled by hydrodistillation because it's a softer, slower process. And you could do it with steam, but because the flowers become really mushy when you heat it up, it tends to block, it tends to coagulate and tends to block, so you can't get steam through it. So it's done in water where the water is constantly boiling so that they stay sort of fluffy and aerated. Fractional distillation, it's also fractional. All distillation is to a degree fractional distillation, because if your oil has a lot of fractions in them or components in them, those fractions all have a boiling point. So those fractions, for instance, anything from 90 degrees up to 400 degrees. So if you are distilling in the distillation process, your lighter components or fractions comes off first, and your heavier fractions comes off later. In most cases, you would have a complete oil that combines all these fractions. But for instance, and this is by chance in my opinion, lang lang, which is a flower that is fractionally distilled. So the distillation process is really long and really slow. It's hydrodistillation because it's a flower. But what happens that they would take off the lighter component, they would split the oil. The first 2 hours is lang lang 1. The second 2 hours is lang lang 2. The second and so forth. I'm not sure how far, but maybe until lang lang 4 or 5. And that's really completely different fractions, although it comes from the same plant. But the lighter fraction is a lot more valued by perfumers. So somewhere along the line, years ago, a perfumer sat next to a stall and decided that this is how it's going to be done. Not because it is, it's just that someone decided, I like that smell more and I can do more with it. And over the centuries, it has become standard. But all distillation could be done like that. It just isn't. Sorry, that's a short example from the field.
No, fantastic. So we're getting a sneak peek of your shop. And so we're going to take the viewer now to see the video of the inside of your shop. So let's go over to the video roll.
Hi, my name is Werner Bester, and we're in Riebeek Kasteel, where my business Essential Distillation Equipment is situated. I'm going to take you through our factory to show you some distillation projects that we're busy with, and then also some trials that we are currently doing. Here's a 2-ton still that will be installed in Madagascar and be used for extracting oil from geranium. This specific still has a remote boiler that there will be 2 different types of boiler. One will be used biomass, the other one will use diesel as a backup. And the machine will be installed in the ground with an overhead crane for ease of material handling, raw material handling. Over here you can see the condenser and the separator for this specific unit. The condenser is used to condense the steam and vapor coming from the boiler through the plant material back into oil and water, which then goes into the separator or Florentine flask, where the oil and water is separated. In this case, the oil is lighter than water, so it will float on top. Here we have a much smaller unit that will be used for a variety of herbs, including tea tree, rosemary, for instance. This specific unit there is no overhead beam, and it will tip over here with a mounted gearbox by hand, and the tipping would then remove your spent material. Here we are testing some machines. I'll take you through the two different ones we are currently working with. This is a socklet extraction that is used for doing herbal extracts from plant material, very various different kinds, including cannabis, which would be one of them. Over here is we are doing a test. This is a hydrodistillation system, which will be for frankincense, once again, just to establish the distillation times and yields for frankincense for a client that we are currently looking at. A test distillation unit, which I'm going to use to explain to you the simple process of steam distillation for essential oils. This specific unit we rent out to customers for tests, for quality and for quantity, and we also do a lot of tests with it in our workshop. The first part of this system would be the boiler or steam generator. This creates steam. The steam then goes from the kettle into the pot. In the pot, you would have your suspended plant material, be it generally herbs or herbaceous type of plant material. This is more suited to. That would be in the pot. The steam would go through the plant material and take the oil vapor with it. Both the oil vapor and the steam in its gaseous form would go into a condenser where it would be cooled down to water and oil. And in this case, it would go into a simple glass separator where your oil would either float on top or go to the bottom. Here we are again with a test still, the 10 kilogram test still. We are going to be doing a test of Celia Zacatecici, just to establish whether there's any oil inside for a client. You can see here, we're filling the pot as far as possible to the top. With the leaves, okay, and then closing the top to get it ready for distilling. Here is a header tank, which is the water towards the kettle, and it also controls the height in the kettle so that it stays at the same height while steam is being boiling off. This is the kettle where the steam is generated. From the kettle, it goes into the pipe, into the back of the still, and from there on it goes down below the plant material and then moves its way through the plant material into the condenser, and the vapor and the steam from the condenser then gets cooled down to water and oil usually. Where it comes out into this case, it's not a continuous type of separator. This is more a lab scale kind of separator. And here you would have either your oil sitting at the bottom if it's heavier than water, or it will be floating at the top if it's lighter than water. If you look over here, you will see a sample we did previously, and there you can actually see the layer of oil on top of the water.
Well, that was really exciting to see the inside of your shop and get a small glimpse into the distillers that you're building. Werner, you are a very strong advocate for distillation as close to source as possible. You've talked about that a lot with me and shared that with other folks in the field. Why is that so important?
There's a lot of reasons. Look, essential oils can be anything from 0.1 or even less than that to 5 or it's up to 10% oil. So firstly, your oil is a lot smaller volume than your actual plant material. So you have an enormous amount of plant material that is being distilled into a really small amount of oil. So firstly, is transport is the simplest. So transport a big volume of stuff is a hell of a lot more expensive than to transport a little amount of stuff. So that's one thing. And if you even if you go, that's just 50 kilometers or 100 miles in your case. Even that makes a difference here. But if you're transporting out of a country, a biomass out of the country to distill it in another country, the costs are incredible. So cost of transport, firstly. Whether that comes in terms of sustainability, if you are transporting anything, there's a lot of
increases the carbon footprint.
There we go. That's what I'm looking for.
Yes, what I'm hearing you say is that moving large volumes of biomass is making a lot of emissions. And in the time of climate change, where we're seeing so many impacts from climate change, the transport is definitely a factor for sustainability. Yes. Is it also a factor for increasing your yield to distill on site?
Yeah, so that would be the next case in point. So if lots of plants, so not all plants, there's some plants that transport quite well. They have no losses of yield, but there's a hell of a lot of other plants that if you after harvest, if the environmental factors makes you lose oil, not just oil, certain fractions that we talked about earlier. So some of those fractions could be missing. I mean, there are plants that dry really well and don't lose any of their quality. There are other it's resin, which you'll be familiar with. The same thing, the resin plugs together. If you leave it too long, it loses some of it. Becomes difficult to handle as well. So all plants have a problem in doing it, transporting it before distillation. Whether it be loss of oil or whether it be degradation of the plant material, that's another factor. Once again, it's not with all, but with most plant material, that is the other factor. The next factor would be if it's a small farmer and a farmer that is, for instance, in the country, transporting it away from him makes his income and profit less, which is, in my opinion, a real big factor, because if he can do it himself, and it's not that technically, people tend to say that distillation is really technically difficult, and it's not. You can teach anyone to do it well, and if it gets taught. And there's a lot of, in the industry and also in the places, there's a lot of perception that it's really complicated. There's people that call master distillers. I can teach anyone to be a master distiller, I think, my opinion. And by taking it away, it really decreases their profit. So more important fact, never mind the emissions and the carbon footprint, etc. Those are the main. There's also a lot of small other factors, but those are the main important ones.
So the reduction in income for the smallholder, the community, or the farmer is really a big socially responsible or ethical issue, where there's
it is, and it's
material at a low price compared to the essential oil. So you're saying that if they distill at source, that they could still sell their essential oil to international buyers instead of just selling their raw material.
There it's got to do with training how to handle it, because that is the case in point that is made by buyers of oil, for instance, in some cases, not all cases, where they would say there's a lot more control, you can keep it clean, it depends on where it's done. But all of those things are things that you can train people to do. It's to decide to just take that away just because it's easier for you or for someone else is, in my opinion, not the right thing to do.
Yeah,
it is not complicated. The handling of it, the distilling of it, the processing of it, it's all things that can be taught, and rather taught at source. Never mind the physical aspects of it, the cost aspects for you. It would also reduce the cost for the consumer and the buyer at the end of the day. Yeah.
So it would reduce cost overall, but increase profit to the smallholder.
Profit to the smaller and to the supplier if he chooses to. But that it does require input training, etc. But it's definitely possible, and it's not that difficult to do.
Yeah. So I'm hearing you say it's possible, and of course that's making me wonder. Then, what are the barriers for farmers and cooperatives and smallholders to distill instead of selling the raw material? What are some of those barriers?
Well,
on a couple.
Look, the cost of the still is the obvious one, depending on the size that they are doing. So the thing about distillation or distillation equipment, the bigger it gets, like anything, it's not related just to essential oils, the cheaper it gets to work with. So that can be overcome if it is a community type distillation, or that gets used by more than one group so that they can band together. And that's been done around the world in any way. All roses in Bulgaria and Turkey are done in that way. There is a co-op. The co-op owns the still. The farmers belong to the co-op. Lots of small farms belong to the co-op, and that's how they distill. The other problems would be training, I suppose, but it's not really a problem. I suppose it's more something that has to be addressed. What else?
So it's really cost. So it's the communities. It's really the communities having the ability to access the equipment. And so in the case of making distilleries appropriate and reducing the cost to communities so that the distillery runs in place well and without using too many resources is one way of lowering that barrier, right?
Yeah.
So
yeah, there is also one other thing is commercial and by the buyers of the oil. It's easier to have your control yourself, and especially with essential oils, there is such a huge margin downstream from after the distillation or after the distilling has taken place, or from the raw material to the distillation, and then from the distillation, the oil to further into the market. Not in all cases, but in many cases, the margins are huge. So that's why in many cases it allows for a buyer of raw material to actually take your plant material out of the country, ship it to another country, distill it in a very more modern facility because of the value added potential of it.
yeah. Yeah.
So it's not a barrier per se, but it is. That's why it's done in a lot of cases.
Right. It's more than.
But it's still that. It's more than norm. It still doesn't make it more profitable for the guy on the ground. But this is not just in essential oils. It's also in many other types of farming.
Sure. Absolutely. So you've worked on some incredible projects. And one of them is called Sense of Namibia. They collect and distill Namibian myrrh, as well as other products and other wildcrafted plants. Can you tell us more about this project?
Yeah, I was a couple of years ago. I was approached by a lady called Cara Knott. She works in Namibia with the Himba community and women. And obviously learned over the years, the Yimba, they use a lot of native plants and ochre and the myrrh, and specifically the myrrh trees in there, so for perfume. They also use, there's other myrrh species that they also use for other things, but the perfume was obviously something which you could maybe market towards the end of it. So she developed, firstly, she got them to start harvesting it. We then did some pilot stills, and myrrh, traditionally myrrh is hydrodistilled. It's also really, really difficult, not traditional myrrh, common myrrh as it is being sold in the world. And the hydrodistillation, with the hydrodistillation myrrh, it's really messy. It's very sticky. You can imagine resin being boiled becomes very sticky, difficult to clean, more difficult to handle. And myrrh has an extra problem, is that as I talked before about the specific gravity of essential oils, myrrh is one of the difficult ones, as it has the specific gravity is really close to water, which makes it difficult to separate, or more difficult to separate. There are lots of other ways to do it, but for simple separation, which you can do in the field, you would normally want to do it with water, not add alcohol or other things that you can. In the lab, there's a lot of things that you could do, but that's a lot more difficult in field to get your product out. So we tried hydrodistillation first on a smaller scale to see how it would work, and it was very messy, didn't work as well. The yields took really long. As it does, I think, in general cases. We decided, because it's a new oil and there's no, I have to explain a bit regarding that. Generally, oils in the world have been distilled for a very long time. And they were distilled in lots of ancient ways. And during the years, maybe only in the 20th century, perfumers obviously got a raw material or an oil from somewhere, and it was in a specific way. The quality was the color, the quality, what's the name, because it was done in a specific type of distillation that someone maybe did in the field, and that became the standard. And that standard, for many other oils, if you are distilling and you're distilling a very common oil, lavender, normal frankincense, that's been around for centuries, you would generally have to conform to that standard of quality of the oil, and that standard can have a lot to do with how you distill it. So myrrh being completely new and novel, and there's no standards for it, as far as I know, we decided to try some other ways of distilling it. So we came up with a steam distillation method with a lot of mechanics changing the distill, but making it a lot simpler to distill it and a hell of a lot quicker. So then we got a really nice oil out. It didn't have to conform to previous standards, and it's slowly getting into the market, and it would be the standard. So there we had a chance to do some innovation in terms of distilling a product that was never distilled before. So you have an idea of how it should be done, but it's very nice to be able to play with it, and then at the end of the day to come up with an oil that doesn't have to conform necessarily to a specific standard.
I see. And that's the
it can become the standard. Yeah, that makes it easier than having to conform. So if you have to conform to a standard, you would generally go to the distillation that is being used, and you would always try and get there. So you can do innovations, but the innovations has got much more to do with the handling, how efficient it can be, how quickly you can do it, while still not damaging the product or the oil, and a lot of other factors. But at the end of the day, the oil still has to conform to, and it's not necessarily quality. This is the best quality, or this is the only one. And then it's really somewhere along the line, someone that dealt with the oil decided that I like this. It's personal. I like this. And then they decided to use it in a product, and lots of other people followed. But that is the way standards for essential oil, or what is perceived as quality in essential oils are made. It doesn't mean it's good or bad or anything. It's the same asking, for instance, which is the best type of lavender. There isn't one. It depends on what your market wants.
Right. And so there's natural variability.
There is, yeah, for sure. Yeah.
And in the outcome from distillation.
Yeah, there is, yeah. But you kind of have to conform within certain parameters. I mean, there's essential oil standards that's around the world, and for GC analysis, for instance, they would have certain components that can be within this range, this range, this range. So there are ranges, obviously, because I mean, it's natural. It will differ. It will differ depending on where it comes from, what the soil, did it rain? There's so many factors that makes it different. But there are ranges, and for it to be considered a good quality oil, it will have to fall within those range. With the Myrrh, as I explained, that was not. More about the other, I just talked about the distillation of the Myrrh. The Himba women who were harvesting it or using it as a perfume anyway, they became part of this project. So they are the harvesters. They are also still was put up in Puo in Namibia. They are also the owners of the still, or part owners of the still, and it's in a conservancy in Namibia. Which, there's a couple of laws that makes it belongs to the state, but it also belongs to the traditional people. So wow. It's a woman empowered project by a woman for women. That's the other nice thing about it. And it also empowers the people. They are nomadic and travel around it. But because the country, population is getting more, they have to buy certain things. And this gives them the opportunity to buy things because the world is changing.
So when you built the still for them, did that really change the project? Was that?
Yeah, of course. They all of a sudden had a product. If you go to the website, you'll see they have different products. But it's a really long process to get any new oil that it doesn't have a standard that's used by perfumery or flavor or fragrance. There's standards that there are. So there's a CAS number that gets assigned to an oil once it's been tested. There's a hell of a lot of tests because it gets used on the human body. So either in perfume or if it's food, it's even worse. So that's the FDA that gets involved. Is it safe? Is the component safe? All of those things. So it has to go through all of those things, which takes years and a lot of money for it to be an approved, get a CAS number where everyone says, okay, this is a safe oil. I can use it. It's been proven safe. So you have to go through, but any new oil, you have to go through that. And it takes time and it's costly. So it's still a long road for them, but look, they have markets. The markets are slowly but surely opening up. They've developed their own products, which is the easiest entry into for any unknown essential oil. That would be the easiest entry into the market. It's a natural product, and the rules and regulation around natural products are a bit more lenient.
Yeah, you mentioned it's a phenomenal project, and we certainly have been showing images from the website, and people can do more research about this project. You also mentioned one in Jamaica.
Oh, that's more interesting than anything else. There's to the case in point of the quality of the oil and how it's been done for centuries. So in Jamaica, they do pimento berry oil, which is a spice, pimento berry and pimento leaf. In spices, they would generally use the spice and lots of times the leaf, and there's an oil from both, and they differ a bit. But they were doing pimento, which went into the flavor industry. But the pimento in the field is done in very old bush stalls, as I explained in the traditional. They would have a pot, could be made out of steel, copper, so sometimes stainless steel. If they were getting, there'd be a fire underneath, and they would distill it, very rudimentary methods. But the oil that came out of that was brown and had a bit of a smoky odor, and the GC was obviously a certain type of, the analysis was of a certain type. So I had a client that asked me to build him the modern still, much bigger than what we've normally seen, because he had they were going to do sort of a community where all the guys, they would pick up the berries, bring it to a communal still. That means a bit more profit and shared, and obviously one single person doing it, but it would make it a lot easier, and the oil could be the cost of the oil or the process to make the oil would be less. So we distilled, and the first oil came out clear, which we sent away, and obviously it didn't conform because of what was expected. And then we had to go back and do some changes to make the modern still produce what the traditional still produced. Otherwise, we couldn't sell the oil. So even though the oil was, the analysis were perfect, the color and the smell was not.
Wow.
So basically, going back into point, it's not where you have to. There's a point where you have to conform to the market.
Wow, to the norms. Werner, what's the future of distillation? You've shared a lot of intriguing concepts and ideas with us. And where do you see the future of distillation going?
Look, the future of distillation has obviously got a lot to do with sustainability and, looking after the small farmer more than we have in the past, making sure that they get enough of an income, using alternative fuel sources as solar energy to a bigger degree, although solar is available. And in the case of generating steam, there are plants, but they are enormous. So there's no really commercial small available. I get a lot of requests for, can I make steam from solar? Yes, you can, but it requires an enormous amount of space to do it from whatever's commercially available. So we are doing work with producing steam with a parabolic solar heater on a smaller scale. Once we figure out that, we would go to obviously to a bigger scale to go further to farm.
Can you explain what that is? A parabolic solar unit?
So there are ways in big solar plants, you would have solar panels. That's one way of doing it. And you would have seen in the States, I think in a lot of countries there are where they would take the heat of the sun. And there are power plants like that available already. They are just really, really big and to generate power for communities or towns or whatever it may be. So you would take the sun, concentrate the heat of the sun with parabolic reflectors. That would then go onto a water source where you would turn the water into steam, which is what we need for distillation. But in that case, you would have it turns into steam. It would be heated up to the point that it would become dry steam, and then it would drive a turbine. And that turbine would generate power in the normal case for generating power. So there are plants like that in the world, many. It's not a new thing. They are just really, really large and concentrated on. So, but even with a coal, it's the same with for instance, coal power plant or many others. There would always be a turbine, something that drives the turbine. So in the coal, for instance, there's not a lot of coal around anymore, but with coal, there would be, you would once again heat your water to a point so hot that it becomes dry steam, and that dry steam would turn a turbine, the turbine would turn a generator, and the generator would generate electricity. But we only want the part where it makes steam, and we don't want the part where it makes really, really hot steam. We're looking for saturated wet steam, not dry steam. We're not trying to drive a turbine. We just want the steam to put through the material. So all of this is possible. It's not commercially available on a smaller scale because it's financially it's maybe not viable to do 50 or 100 small farmers is not enough to justify developing something like that. So we are trying to develop that. The further steam generation that we're doing is from biomass, and that's also not new. It's just to make it efficient. So the French farmers they've got a boiler where they take the lavender that's been taken out of the still, they bring it back, dry it, bring it back, and they feed it by hand into a fire, and the fire generates enough steam, and that produces steam for the distillation. But they are really inefficient and old. So we are trying to do a much more modern version of that to try and make it efficient use of the plant material. Because it will work. It won't work for everything. It will, for instance, not work for resin. Resin doesn't burn that well after it comes out of the still. But for nearly all plant wood, even seeds in some of them, you are making a hell of a lot of biomass that you've got to do something with it. So either you turn it into energy, which is possible once again, but in the same sense as the solar, it's really, really big, the commercial units available, because of to do that kind of development and you have to have a market that is big enough that can buy this thing that I've developed, and many of them to be able for a business to make a profit. So that's in terms of steam generation. Then also in terms of water usage, there's a lot of innovation that can be done, which is also not new in industry. It's just not being done so much on distillation. So it's more to adapt it to that purpose. Water usage, water reusage, use of waste heat, because there's an incredible amount of waste heat generated for the distillation process. And for instance, though, the cooling tower that I said, that you're making heat, you're putting it through another cooling tower, which also uses energy to be able to get it back when it's cold enough for the distillation. So you are and that energy then goes up into the air. So there's so much waste energy, and not just in distillation, there's a lot of waste energy that can be utilized for something. So preferably back into the system or something else around the system, or even in a human capacity. I remember we had once where they used the wastewater to go into a geyser, and the geyser gave people a hot shower. That was one thing that we. So there's a lot of that's more the kind of innovations that I see, and then also just to look after the small farmer and make sure he makes a profit, because there's a lot of big business that make profit. It would be nice if the small farmer can have some of that.
Future of distillation is more in kind of these two categories: the income and looking after the small farmer, right, and giving them stills at source that are designed appropriately and as efficient as possible, because the cost is a barrier for them. So that's why I'm really looking for these stills that take the least amount of energy, that use the least amount of water, and that can be created properly for that situation, is where the future of distillation
there's lots of other innovations which are being done, but do with distillation continuous, which work with some wood types. There are micro distillation, which hasn't really found its place. There could be there's a lot of other new things you find with distillation, but those are smaller things. The bigger things, in my opinion, is the biggest thing where you can make a big difference is usage, sustainability, looking after the farmer, and efficiency of distillation. So what we're doing is an ancient thing. It's not a new thing. It's been done for centuries. It's just to make it accessible, easy, efficient. Those kind of things, in my opinion, is innovations in distillation. There are proper more. There's obviously more scientific innovations that can come along too. But those are the simple things which will make a big difference.
Yeah. I think you love what you do. Do you love doing this kind of work?
I do.
Is it exciting to create?
It's exciting. You are learning. This is the thing about essential oils. Never mind the distillation, the flowers, and the plants. I make plants too. I work with. We do analysis of oils. To find back from the plants. How do plants grow? In a certain sense, in South Africa, we have indigenous plants. There's very little of it being introduced into the world. Although we have one of the biggest floral kingdoms in the world in the Western Cape, very little of it gets used in essential oils. So we are trying to do a work with that, where you grow it, where you process it a certain way. What happens at growing at the growing level, at a seed level, at the distillation level, at all of those changes what happens in your oil at the end of the day. So the other innovation, that I didn't talk about is where you would have a market that wants a certain fraction or more of a certain fraction in the oil, and then to actually having the knowledge boil down from that side and having the farmer distill that or grow that plant in a certain way with experience to produce more of what the client wants. Mm-hmm. That connection between the client and the farmer is very rarely there. There's middlemen in between, and nothing gets filtered down to the farmer or gets filtered back to the supplier in many cases, or the end user in many cases. And that would help a lot if the end user explains and helps the farmer get to that point to what he can deliver. So for me, I'm doing that in terms of plants that are from my country or my area and trying to introduce them to the market. And that I've been doing that for a long time. And some of them are getting there and some of them are not.
And you're busy. I mean, you're building a lot of skills and you're really in demand, which I know that about you. And that's a really good indication that more and more communities and places are moving towards distillation closer to source. And so you're really an instrumental part in helping communities and smallholders to realize that vision of distillation closer to source because they need the engineering support.
Yeah, because it's it really is. I mean, it's a big industry, but it's my side of it. It's really not that big if you look at it worldwide compared to other farming industries. So there's very few people that specialize in it. So I try and specialize it in it and all the parts of it, because understanding the plant, understanding how it grows, understanding the distillation, what happens in the distillation and the processing from the field to the distillation, and then from the distillation, what happens with the oil, where the problems that can get into that. And then when it gets to the fractionation or the fractions of the oil, understanding the whole process makes what we do very different. There's very few people doing all of that. And that makes it fun too. That's why I love what I'm doing, because it's always new, always innovative. There's no time that I'm not learning something new from some farmer that you would never think, or someone else would never think you would learn basic knowledge, which is just not there. Yeah. So I like learning. That's why I like it.
Something new to learn about plants.
Yeah, it's fun. It's always innovative. And I mean, that's the other thing on the other side of science, that what happens in science, in medicine, in flavor and fragrance, that's constantly new, and that filters down that it's always going forward. I mean, this is an incredibly innovative industry, and what happens on that side of it.
Mm-hmm. That's fantastic.
That should boil down back to the farmer too. That's right. Yeah. Anyway.
Yeah, well, let's hope, as you're saying, that's the future for distillation. So we want to tell the viewers that today is a brief introduction. And really what Werner and I are thinking about is going forward, making some webinars, some workshops for people who are interested in distillation at source and want to know more about it, to have an online workshop space for that to happen with Werner, which is an amazing opportunity because he's very in demand. People aren't really traveling right now with the current global situation, especially not those of us in the United States. And so doing this kind of work online, it's okay, you can giggle at us a little bit, doing this work online and having this access without having to go anywhere to do this online is an extraordinary opportunity, Werner. And I also want to note that this is Werner's first time to do this webinar and start presenting this information publicly this way. So we're very lucky and we feel very fortunate to be a partner of yours, Werner, at the Aromatic Plant Research Center, to work with people like you all over the globe who are just driving innovation and teaching people all kinds of things about plants, distillations. So thank you so much for being here today. This is hopefully the first webinar you'll do, Werner. You'll do hopefully many more. And, and are there any last comments that you'd like to say to the audience?
No, it's fun. It's fun. It's also good. I mean, generally, the only people I speak to are people that phone me or for information, and also all my clients that I learn from and that learn from me. So it's good to. That was always the idea with what I'm doing. At the end of the day, you know, you need to give your information over, and I'm a very big believer of that. I do believe that information should be going forward, not be lost with a person. So all good.
Well, and that's another unique thing about you, is that you want to share openly information and educate so that people can advance the industry, so that and that deep core belief of the small farmer and the community organizations having a part in this, a more substantial part in this. And so just wonderful. Thank you so much. And now we're going to switch over to the live Q&A, where people can ask questions directly to Werner. So if you want to go ahead and type in questions, I've been watching them while they're coming in. We can field a couple questions. Hi, everyone. If you have any questions that you'd like to put in the chat box, Werner's coming on right now, and we can get those questions to him. We only have 10 minutes for the Q&A, and we can start with some of the questions that went by in the chat box already. Werner, are you there? And we can start with some of the questions that went by in the chat box already.
Hi, everyone.
Werner, are you there?
I am.
Great. So, Werner, we have more questions for you than we have time to answer. And so we certainly want people to know that they can follow up with you directly. So, one of the first ones, then we have time to answer. Do you have your earphones on? That they can follow up with you directly. So one of the first ones, then we have time to answer. Do you have your earphones on? Sorry, we'll get that reverb settled here in a second, everyone. So one of the first ones, then we have time to answer. Do you have your earphones on? Sorry, we'll get that reverb settled here in a second, everyone. So one of the first ones, do you have your earphones on? Sorry, we'll get that reverb settled here in a second, everyone. To those of you who are asking about whether or not the webinar will be reposted, absolutely yes. All webinars after they've gone live will be posted on the Research Aromatica webpage, so they can be accessed at any time, and you can certainly link them and use them and share them accordingly. Oh, we have some amazing people on the webinar today. Dr. Brian Lawrence is with us, Dr. Prabodh Satyal. We have many people from South Africa. It's really amazing to see the international crowd showing up. Okay, I think we're settled on the headphones now. Werner, Dr. Brian Lawrence has been asking us some big questions. Do you have an opinion on the efficiency of distillation as explored from oil to water ratio in the separator? Is a question from Brian Lawrence.
I don't know if anyone can hear me. There's a big delay. I'm hearing you in my ear. Excuse me. Very delayed. Hi, Brian. Really nice to to have you here. Yeah, sorry, I'm hearing. Okay. Efficiency of distillation is explored from the oil-water ratio in the separator. Sorry, in my ear, I'm hearing 2 minutes later. There is a real lag. I don't know if anyone else is experiencing it as well. You're talking about the water entrained in the separator, or is it the soluble component of the essential oil, or is it just just oil that doesn't separate completely? Sorry, Brian.
There very well might be a lag on his side as well.
Is it? Yeah, it's
yeah.
Sorry, but it's not.
It's okay. It's the technology. I mean, we're right
now
now all over the globe doing this, so it's to be
Yeah.
expected that there's a little lag. Well, we'll come back to that. So you had a question early on while you were talking where someone was asking that they've seen crystals forming in the plant material during hydrodistillation. Have you ever seen that before? Is that something you've ever come across? So we're really having a technical glitch.
Well, no, I haven't. I've seen crystals in essential oil. Buchu has crystals, crystallization of essential oil. It's got some of the components. I have not seen it in hydrodistillation. No, sorry.
Okay, great. So is essential oils from steam going to be deemed an acceptable standard, Werner, in essential oils?
Steam is not one of the only ways. There are a lot of ways.
And do you see that as a acceptable standard for the essential oil industry?
Ooh, I'm hearing three voices over each other.
Well, how about we do this? I think we put your website up and a way to contact you. You did a great job, Werner, of answering many of the questions during the chat section. And as technology is, there's just glitches sometimes. And so we can definitely follow up with any of the questions people ask by contacting Werner or me directly and getting that to Werner. And so we're really happy to have all of you here today. It was great to see over 85 people attending. And we hope that you also will submit topics and possibly do presentations yourselves. We really want to open this platform up to have more international folks from all around the globe presenting on topics.
It's a lot better now.
Ah, okay. Well, if there's any last minute questions for Werner, he's willing to hang out. He's got just a couple more minutes. We had one from Denzel.
Let's start again. Yes.
Okay, we have one from Denzel about the energy efficiency he asked early on of the units and that being an important factor. And now he's asking about if you leave mentha arvenis oil, will you find crystals?
Yeah, you will find crystals. Yeah. So there are some oils that will form crystals with hydrodistillation, not specifically. Yes. Okay, so that's one. Can we go to the next? We have considered building CO2 units. We are doing CO2 units for cannabis and also solvent extraction for cannabis. Bernardo Starling shapes of the distillers. Generally, steam distillation is long. Is quite. You try and keep the diameter as small as possible and make it reasonably long, not too long, otherwise it becomes uncomfortable. Where hydrodistillers would normally be more short and squat, to keep the radius, the diameter of the pot low, you use less steam to process the same amount of process. Brian, sorry, I haven't answered. You have many questions. I'd really like to have a discussion with you in private one day. You have an opinion about the efficiency of distillation as explored from the oil water to the separator. I think we discussed that. What is the next? Sorry, it's a 10 kilo distillation. It was a 40 liter. And the plant that we were doing is just, one of my engineers brought a plant from home, something Yakatichichi. There was no oil in it. He personally wanted to find out, and we had to distill something. It's winter year, and there's not a lot of plants that are ready for distillation. So that one was not really, it was just to see personally if there was any oil in it.
Great. Yeah, Werner, we didn't really talk today about the work you're doing with cannabis. However, both APRC and your shop are both doing a lot of work on cannabis. And so we will in September be doing webinars around formulating with cannabis and testing cannabis. And of course, again, Werner is an amazing resource for cannabis work. So, like we said, there's always something new in plants and aromatics, and cannabis is certainly a hot topic right now. I think we're going to close it there. Thank you to all of the viewers. It's wonderful to have you here and to have so many esteemed colleagues joining from all over the world. And we hope to see you at the next webinar in 2 weeks from now. Thank you so much.
Thank you, and thank you, everyone. And yeah, anyone who has other questions, my website address was up, so please feel free to contact me there.
Wonderful. Thanks so much, Werner.